right, let's get into this lecture where I'm going to be explaining the rest of the time value tables. Now, we went over the compounding interest table, which is pretty basic, and it's an easy one to get started with because most people are pretty familiar with compound interest. Now we start to go into just a little more complicated of tables, which the tables aren't any more complicated than the compound interest table. It's used the same way. You identify the periods that it's going to compound and you identify the interest rate at which it's going to compound. But the difference is, at this point, it actually becomes harder trying to figure out which timetable to use. So I'm going to go through the timetables, the 4 of them that are the pretty common ones that you use, and kind of give a brief overview of what you use them for and what type of situation you'd use them in. So the first one we went over is the compound interest table. Under the compound interest, you have one lump sum of money. So one lump. Okay, that's important. And the other thing that you're looking for with compound interest is you're trying to figure out what the future value is. So that's the unknown, what is going to be in the future. Then the second one you have is the future, this sounds really fancy, the future value of a series of deposits. Sometimes it'll say future value of an annuity, which an annuity is a series of deposits. It means the same thing. So series of deposits or annuities, same thing. So the difference between compound interest, you put one lump of money in the bank and you leave it there for a set amount of time. You just want to know what it's going to be worth in the future. Future value is different. You have a series of payments. So I'm going to put $1,000 in, let's say this month. I'm going to put $1,000 in next month, $1,000 in the next, $1,000 in the next, $1,000 in the next. So it's a series of payments or series of deposits that you're putting in. Like think retirement account. I'm putting a series of payments into that retirement account. It is like compound interest because we still don't know. We're looking for what that future value is. The only difference between this one and this one is it's a series of payments. So instead of just figuring out what one lump is, we are figuring out what a series of lumps at a certain interest rate, what it's going to be in the future. Then we have the present value. Present value of a single amount. So not to scare you, but this is sometimes where students' heads kind of go like this, like, what in the world are we learning here? I don't get this, and their brains kind of fry. So hold up with me for a sec. It's not as scary as it sounds, and it's actually quite simple once you think about it. You just need to slow yourself down and think this through. So present value of a single amount. So this is, I want to buy a house, and I know what the future amount is, but I need, let's say, a $10,000 for a house payment in the future. So in 5 years, I know I want $10,000 for a house payment. So the future is unlike these two. The future is known. I know what I want. I just don't know how to get there. So I need to know the present. What's the present value to get me where I want to go? And present value of a single amount, it's one lump of money, not a whole bunch of lumps. It's, if I want $10,000 in 5 years, what do I need to go to my bank and deposit today so it will grow with interest and be that future lump that I want? So we're looking, we know the future, and we're working backwards to the present. The present is the unknown. So when we're working with present value of a single amount, just think about it, and when you read the title, it tells you we're trying to figure out what the present value of a future amount is, and it's a single amount. So that means it's one lump of cash. The last one is the present value of a series of deposits. Can't spell. Present value of a series of deposits. So on this one, we're again looking at the present. We don't know it. We know what we need in the future. And in this case, the future up here, we knew what the target was. So we knew the target. We knew that we wanted $10,000 for the house down payment. In this case, we are looking for the future. We know what we want. It's known. But the target, instead of being one amount, it's, for example, over the weekend, we took my son down to college and dropped him off. So he has 2 years left, but if you're planning ahead for your child when they graduate from high school and go to college, they usually have 4 years. So a very conservative estimate would be you need at least $10,000 a year for college. So for year 1, you need $10,000. Year 2, you need $10,000. Year 3, $10,000. Year 4, $10,000. Unless you go to a great college like North Central and get your first 2 years done much more efficiently and economically. So year 1, year 2, year 3, year 4. So technically you need $40,000, but you're not going to be pulling it out the first year. You're just going to be pulling out as you need it. So it's a series of deposits. So present value of a series of deposits. So in the future, I'm going to need to make 4 withdrawals of a certain amount. So what do I need to do to go to the bank today to deposit a certain amount so that in however many years I have, say your child is 3, you have 15 years to prepare. So in 15 years, you will have enough there that you can withdraw $10,000, $10,000, $10,000, $10,000 for 4 years. So present value, that's what we're trying to figure out, series of deposits. So that'll indicate that that is the chart that you're supposed to be using. And I noticed that I can't count right here. That's 3. This is 4. Got ahead of myself. Jeez, oh Pete. All right. So the 2 questions you should ask yourself when you are given a problem and you're trying to figure out which chart to use, ask yourself, is it a lump or is it a series? Because if it's a lump, you're going to be using compound interest tables, or you're going to be using the present value of a single amount table. So one lump is going to narrow it down to those 2. And then you could ask yourself, are we trying to figure out the future? Is that the unknown? Or are we trying to figure out the present? Are we working backwards to the present, or are we working towards the future? Future value of a series of deposit, present value of a series, they both involve series of payments. And then again, you ask yourself, are you working, what is the future unknown? You're working towards that, you want to know what it is, or are you working backwards to the present? So if you can answer those 2 questions, you can narrow it down to what 2 charts that you're going to be using.